Hello, Franz here, Clay Manufacturing. This video is for doing the cam operations, cam op 1, the top side of the Wasabi, which is a speed wrench. So this is for doing all these tool paths right here for the top side of this to complete the machining operations. Let's zoom into my pretty face a little bit. This is my older version. This is kind of what the end product looks like. There's a bearing pressed in here. I'm redoing this whole thing, so it's gonna look kind of similar, but also different. It's gonna be a little bit shorter. I'm gonna do it different. And then I'm doing some changes to a little detail finish work in here. And so this is my old version right here. And then this is kind of the newer version right here. And we do some finished detail work in here. We do some blending. So I'm going to open this up. I'm recovering from a cold, so I don't know how this is going to go. My throat is already hurting. But our learning objectives for this are 3D adaptive roughing. So we're going to kind of go over, we're going to utilize 3D adaptive roughing. We're going to do finished contouring. So our finished strategy to clean the outside of this puppy up and some of these kind of stands. We're going to do how to actually go inside a pocket in our feeds and speeds for doing a tight pocket with a relatively big end mill without doing a pre-drill in the center. We're going to do rigid tapping. So if your machine does not have rigid tapping, you're just going to have to drill a hole and then tap it by hand. And blending perpendicular surfaces. So let's see. On my old version, I used a square end mill for cutting in these details around these stands, so it's just like a 90-degree transition, and a lot of gunk gets stuck in there. Same with the bottom of these pockets. It's just a 90-degree end mill. Now you could use a radius end mill or a bullnose end mill to do that, but because we have limited tool holding capacity in my machine, so I'm going to utilize an 1/8" ball end mill to blend these transitions. It's kind of cruddy here, you can't see that well, but we're going to go over how to do that. We're going to go over how to do some detail in here with our 1/8" ball end mill to make it look pretty, if you can see. And then you blend this pocket, or this edge right here is also blended with that 1/8" ball, so it's a nice smooth radius, so gunk hopefully won't get stuck in there as easy. And then we're going to do some 3D horizontal finish work on this top web is what I call it. And that's about it. Let's get to it. I'm going to try not to make this video more than 30 minutes. So if it approaches that 30-minute mark, then I will change Op 1 into 2 different videos. So it'll be Op 1 Part 1 and Op 1 Part 2. But we'll see how it goes. Let's close this out. I've got my water to help get my throat through it a little bit longer. Let's see. Did I like that? Keeps it kind of smushed over there. All right, let's get to it. So the first thing, let's go to where we left off of. This is our end goal. We left off here, which is our 3D CAD. So this is where you should be. So what I'm going to do for my purposes, I'm just going to go File. I'm going to say Save As. And this is going to be, I'm going to change this to Cam Op 1 Video Demo. And I'm just saving it over here. You can save it however you want. And I have my new version, and here we go. So this is going to be my Op 1. Now the next thing I need to do, I need to go to my manufacturer environment. So I'm going to come up here to the upper left and go from Design to Manufacture. All right, we're in here. Now I need to specify what my stock is. That's the raw stock. So this one's been cut, of course, but I need to tell it what this length is in X, what kind of the width is in Y, and what my thickness is in Z. And I mean, you want to try to get it pretty close. So if your saw is not accurate, I would cut your stock first and then measure your stock with calipers or tape measure. You can get pretty close with tape measure. And this one measures, it's about 5.625. I'm going to say 5 point. Yeah. So it's about 5 5/8. I'm just measuring the length. All right. I'm going so slow. We'll go setup, and I'll say new setup. And the first thing I'm going to do is, I was just wasting so much time, I'm going to go to stock. And for mode, I don't want relative, I want fixed, because I know what size I'm starting with. So I'll go fixed size box. Now WCS is going, it's going the correct direction. So I have X going to the right, Y going away from me, and Z going up. So now when I populate these parameters, it will get bigger or smaller in the dimensions I want it to. If not, you need to get your orientation of your work coordinate system set up first. So that way, when you populate these numbers, it's going in the right direction that you want it to in the machine. So since my work coordinate system, the arrows are going the correct directions, I'm just going to populate this. So I'm going to say my X dimension is 5 5/8, which is 5.625. And then I'm going to leave that in the center. My depth, I'm starting with 1x2 stock. So this is dependent on me starting with 1x2 stock. It is not the most cost effective, but I use it for soft jaws on a whole lot of other parts. So that's why I'm doing it. 2 inches. And then my height is 1. Now, the thing we want to be careful of is I want my model to be at the top of the stock, but with a 20 thou offset, because we're going to machine that off. And Fusion updates it where the part is in the center of the stock. So I'll go offset from top positive, and then it defaults to trying to keep it in the middle. And I'm going to say, nope. We're going to say 0.02. And now you see, when I look at it from the side, there's a 20 thou amount of material that we're going to cut off with a face mill. So my stock is looking good, and just do like a top view. Kind of look at it, make sure your model is in here. And if you're using a crappy saw, if it's not cutting perpendicular, you might want to cut a longer piece of stock to ensure that when you do your roughing and finishing, that you're cleaning up both ends so there's no saw cuts visible. Everything looks good. Oh, or does it? Now we've got to tell it, where do I want my work coordinate system? How am I going to touch off my work? So I want to move this to this back left corner, because it's pretty common that you'll use like a back left corner for your work coordinate system. So you'll pick up the X, Y, and Z will be the top of the part. Let's go setup, and this is for stock box point. So it's based off the stock, which is what we want. And then for the box point, with this highlighted, I'll just come over here and click that. And you can double check yourself. That looks good. X is going right positive, Y is going positive away, and Z is positive up. Everything looks killer. And look at your view cube too. Everything's looking similar to mine, and it's a 3-axis milling machine, so I like to model all my detail from the top, and I'll say okay. There's our setup. The next one I'm going to do is a face tool path, and that's in the 2D face. And I'm going to go to my not that. I'm going to go to my mini mill aluminum, and I have tool 1. It's almost a 2.5-inch face mill. Select. And for me, my default feeds and speeds these are going to work well. 6,000. Everything I put in here, I have machined, and it works great on a Haas mini mill. And if you've got a smaller machine, you might have to detune it. If you've got a bigger machine, you might be able to get more aggressive with it. So this looks good. Let's go to our geometry. I'm not going to select anything in here. The defaults are good. For my heights, I don't have to do anything, because it says my bottom height is my model's top. Looking good. Passes tab, what I am going to do, so I don't do 2 step overs, I want 1 clean pass. I'm going to change the step over to 2.3. And we'll go 2.3. And let's go to and that's right here. And let's go to my linking tab. I'm not going to do anything. And let's just see how it looks. You know, John Saunders, what he says is like, he kind of, in one of the videos, he does as little as possible and then kind of goes in and edits it. It was like a lathe video I was watching, but I like that strategy. Just kind of like do the basics, make sure you get a tool path working before you screw with everything, and then kind of fine tune it. So that's looking good. And I'm just going to go save, so I can save my work in case I lose internet connection, or my computer crashes, or my power goes out, because we're in California, so our power loves to go out all the time. Now the next one I want to do is, I cleaned up the top. Now why I have supporting material on the inside and the outside, I'm going to pop these holes in here, and those are just clearance holes, because this is to fit around a hex handle. So the way I easily do it on a mill is I just clearance them with those holes. So we're going to go drilling. I'll say drill. And we'll go to my tool library. And so this is for my mini mill, and this is posted on my website. I might need to update it. So shoot me comments if you look and it's not updated, or I'll check it. But I have an 1/8 inch cobalt drill. It's actually the one I'm using is a high-speed drill, but this will work. So it's my T8 1/8 inch drill. I'm going to say select. And for me, these parameters work well. And on here, I look up what's recommended to feed per rev by the manufacturer, and I kind of detune it from what most manufacturers recommend because I'm just on a mini mill and I'm trying to go nice and easy. Geometry, now I need to select all these holes, and I can select through the part, as you see. Come on, baby. Oh, so I got 12. Oh, I missed one. You see that? Come on, guys. Why didn't you tell me that? All right, now I have 12 faces, and I'm just selecting those. And if you look, we're going to go to our heights tab. It defaults to where the tip of the drill just goes to my model bottom, but I want those holes to go all the way through. So for bottom height, I'll go drill tip through bottom. So there you go. And if you do that, oftentimes there'll be a real heavy burr. So I'm going to poke through just a little bit more. So my drill through depth, or when I'm flip it over, if I don't hit my nominal size of 625, if it's a little bit thicker, I want to ensure that it's removed. So I'll say breakthrough depth of 10 thou. And you see how that straight edge goes 10 thou past the bottom. Love it. Now I'm going to go here to my cycle tab. I want to go drilling, and I'm going to do deep drilling full retract. And I'll do pecking depth. So the first one will be 0.3. And then I'm going to reduce it to 0.125, and then my minimum pecking. So each time it pecks, it'll reduce by 0.125. And then when it gets to a minimum of 0.125, it'll be 0.125 after that. And you can hover over these and get a better explanation. I just don't have the time to do that in these short videos. I'm going to say, okay, we're 12 minutes in and I'm on my second toolpath. I'm probably going to have to do 2 videos. Next one, we are going to rough out this whole body. I want to just go ahead and adaptive rough this whole thing out. We want to do 3D, and I'm going to do, I believe, adaptive clearing. So 3D adaptive clearing, click. And I'm going to use my 3/8 flat end mill. I'm going to go select. And for me, on my clay stuff, that's my tool 2. I'm going to say select. Now, I default to pretty slow linear feed rate. We are going to bump this baby up to 60 inches a minute. So cutting feed 60, 60, 60. We're going to leave these defaults, and my spindle maxes out at 6,000, so I'm leaving it at 6,000. We're going to go to geometry. I'm not going to do anything, but I am going to deselect my rest machining. Let's go to my heights tab. We got to do my trick. So for bottom height, it goes to model bottom, which is right here. And that number is based off the stock. It's referencing the stock because my part thickness is 625 plus another 20 thou is 645. Let's do this. And if I look, it stops right there, but I want to shoot past the bottom to ensure when I flip it over, it gets cleaned up. So I'm going to go 20 thou past. I'm going to go minus 0.02. And this is all, these heights are based on 1-inch thick stock using your standard Kurt vise with the standard hard jaws that come on a Kurt vise, using 1.625 tall parallel. So that's 1 5/8 parallel. So it's typically the tallest parallel set in a common parallel kit, and they're 1/8 inch wide parallel. So all this will work considering that setup is the same. If your setup is different, you need to verify your heights and just verify everything, really. Passes tab. Let's see, stock to leaf, I'm going to reduce this to a much smaller number, say 0.005, and that the axial will update to 0.005, and then let's see, I need to also come up here. So my max roughing step down, I'm going to say 0.7, so I changed my max roughing step down to 0.7. Fine step down, I'm going to increase this number to 0.125. Flat area detection, I'm going to remove that. And I have notes, so I'm kind of just verifying my notes so I don't have to do this 4 million times. Oh, optimal load. My default optimal load I have, it's 0.05 times the cutter diameter, but I'm going to do 0.1, yeah, 10% times the diameter, and it's going to be 0.0375. So optimal load is like your width of cut. It's kind of like the step over that it tries to maintain during this adaptive roughing strategy, which is to remove material as fast as possible. So I have my optimal load, boom, minimum cutting radius, okay, direction, 0.7. I'm just going through here, giving you time to catch up, slackers. Stock, good. And then I like to do smoothing. I kind of default that on every toolpath. For this, I don't need to do feed optimization. And let's go to linking. I'm looking at my notes. I'm just running down my numbers, seeing what I did or didn't change. And what you could do, you could select the entry position. On my setup in my machine, how I have it, this would be like the front right corner. So if it doesn't automatically put your toolpath starting here, I recommend doing this and selecting an entry position. So that way when the tool is approaching, you can watch it better versus when it's behind the part. And with the new Haas machines, they have the door locks and everything. So it's really hard to see what's going on behind the part. So I recommend trying to start your toolpaths where you can see them. I'm going to say okay and just see where the default is. And look, this red arrow right here, that's where it's going to plunge it down. So I like it. And this green one going up is where the tool is going to retract between tool changes. So I like that. It's my front right corner, and this roughs out the whole part. If it's cutting up here, it means you did not deselect the flat area detection. So we already faced that, so it's finished and pretty. We don't need to cut it again. We want to leave a little bit of material on here so we can come back and clean it up with a horizontal. And then we have material here on this wall that we're going to actually clean up with our ball end mill. And it kind of cuts over, you see how it kind of cuts over here? So that's all looking fine. And we're going to save our work so we don't lose anything. And this is looking great. Now, if these lines look too spread apart, it means you didn't look at your optimal load, and that's really important, because if you go at 60 inches a minute and do like a huge like 0.2 optimal load, you're probably going to break an end mill. That's looking killer. So let's go. The next one, we're going to cut out these pockets. So you see this one, how it, shoot, let me check something. Oh no. He did bad. All right, I'm going to do some editing. So on this one, on the adaptive, I didn't let it cut in here. So I think I know what I need to find. You see, it's cutting in here. I did a whole entire, because I don't want to go 60 inches a minute in here, because that's going to be way too fast. So I created another toolpath to do that. So let's do, I don't want it to cut in here. So I'm going to right click on here. I'm going to say edit. Let's go to linking. I'm sure I overlooked something here. Or let's go to passes. So now I'm going to click on passes. Ooh, this is it. This is what I missed here because I'm a dingus. Machine cavities. I want to get rid of that. So I did a right click, edit. I'm on my passes tab and I want to deselect this. So I'm going to click on it and now it is not selected anymore. And I'm going to say okay. Oh, that was the money maker. So now it didn't clean those up. And the reason I'm doing a separate toolpath is because this one's at 60. I'm just trying to rough it. I cannot rough at 60 inches a minute in here. It's too fast for that small area. It'll break my end mill or give me excessive chatter. So I'm going to do another pocket, but it's going to be a 2D pocket. And let's say save so I don't lose any data. We're getting to about 20 minutes. So I still got 10 more minutes. We're going to see how many toolpaths we can knock out within 30 minutes total. Let's go 2D. We'll say 2D pocket. I'm going to do my 3/8 flat. I'm going to leave 6,000 RPM. We're going to go real slow. We're going to go 15 inches a minute because that's linear feed rate of the center of the tool. And when it's whipping around these corners, the surface speed of that tool is going extremely fast because it's a real small area. And so it's just whipping around in there. So 15 inches a minute is actually pretty quick in our situation. So cutting feed is 15, lead in, lead out 15. I'm going to leave that, and that's going to work great for my setup. And then if you're unfamiliar with this, whenever you're kind of figuring out toolpaths to begin with, one of the most important things to look at is your feed per feed per tooth. There we go. I'm 6, so I'm allowed to make mistakes. So my feed per tooth on an end mill is what I look up. And all the tooling manufacturers have recommended feed per tooth. And this is very, very slow. Usually, probably I don't go much over 3 thou, which this is even under it. This is 8/10, and it's because my feed rate is so small. It's dependent on your RPM and linear feed rate. And anyways, most times in aluminum, I'll just max out my RPM and then adjust my linear feed rate to get the appropriate feed per tooth. I don't want to keep this video going, so anyways, there's just some sprinkled in advice in there. Now let's go to geometry. Oh, I lost internet. This is why we save all the time, people. So let's see how I'm going to go about this. Let's say, okay, let's look at my internet. Yes, it's Big Daddy. And I'm going to say connect. There we go. I think we're connected. This is why you save all the time. If you're not connected to the internet and you save, it will not save, at least in my experience. Let's click on here. Oh, good. We're going to see what happens. I have a pretty good computer, so if you have a lesser computer, this is probably more common to happen also, crashing. All right, now it says we're back online. Everything's looking dandy, but I lost my work where I was at. So that toolpath, so we were at 2D pocket. And I have my 3/8 flat end mill, and then I changed it to 15 inches a minute. And I jabbered on about feed per tooth. There we go. Now my next one is, what are we going to select? I'm going to come down here and select the bottom edge, and the blue is where it's going to cut. Same for here. Perfect. And that's going to be that. Now I'm going to go to Heights tab, and you know my secret sauce. All these are pretty good, but bottom height is that selected contour, and for here, I'm just going to go 10 thou past the bottom. Negative 0.01. And you can look from the side too to verify. Well, it's not showing now. We'll look at the toolpath later. Everything's trying to be difficult right now. All right, passes tab. We're going to change stock to leave to 10 thou on the radial. That's on the side of the tool. So on the side walls, we're going to leave 10 thou, 0.01. Under the tool on the bottom, I don't care about that surface finish because it's going to get milled away. So I'm going to go 0.0. And I'm going to do smoothing. I'm also going to do feed optimization, and I'm going to leave these defaults. And so, oh, actually I lied. I'm going to change this radius to a 0.125. So this is saying when the radius is 0.125 or under, it will default to a linear feed rate of 3.75 inches a minute. So in the really tight corners where there's a lot of load on that tool, where it's likely to get chatter or break, it's going to slow it down even more. And then it'll speed back up to that initial 15 inches a minute on the straight non-radius or radius over 0.125 inches a minute. Okay. And I'm just looking at my notes. We're going to go to linking. We might have to do some modifications here. So typically, it's more efficient if you are able to plunge with a drill. Like if I'm using 3/8 end mill, I could plunge with like a 1/2 inch drill, plunge right in the center of these hexes. And then with a 3/8 end mill or 1/2 inch end mill, I could plunge in that drill hole and then immediately get to do an adaptive. But depending on your tooling, depending on what tooling you actually have loaded in your machine too, you might, or doing a tool change. Is it faster to pre-drill and then come back and chase it with and then open it up, and you have to use a tool change in between, or is it quicker to just helix down with an end mill and then start doing your adaptive rough? Those are decisions you're gonna have to figure out. For me in this situation, we're gonna helix in with a end mill because I don't have a 1/2 inch drill because I'm a poor man. And then what I have to do, because it defaults to this big helical ramp diameter, so it won't allow the tool to helic and go in, so we have to reduce that number. I'm going to say 0.1, and then minimum ramp diameter, I'm going to say 0.1, and I'll show you what I'm changing. I'm going to say, okay. So this is that helic that we just did. And I know I just realized I forgot to do something. Yeah, I need to change my step over. But this is what we adjusted because it default too big to actually go in there. And so let's go on here. I'm going to right click another time. I'm going to say edit, and let's go to passes tab. And this is what I want to change. My maximum step over. It defaulted to that large number. We want to reduce it to 10% of our tool. So in this case, it's 0.0375. And that's just 0.1 times my cutting tool diameter. Now let's look at it. There we go. So it's going to helix in, and then it's going to do your about 38 thou step overs. And these yellow lines are where the feed optimization is enabled. And that green is kind of going from this tool path to that tool path. And I like what I see. And if you notice this is the leftover material. And you see how it's got this kind of little ramp on the end, or like almost a cusp where it gets thicker. It's because the diameter of the tool only allows it to remove so much material. So we're gonna, when we clean it up, we're gonna use a 1/4 inch end mill to make sure that it doesn't leave kind of a little like scallop type deal on the end. And I'm gonna save. Yes, so the next one, we're gonna clean that up while we're down here. We're at 26 minutes, great. We'll go, and then actually, don't yell at me. I'm just looking at my other one to verify. Yep, that looks good. And I'm verifying with this because I've cut it. I know you're not gonna crash if you're using all my same tooling and machine setup. That looks good. Let's do a 2D, and we're going to do a contour. Now this is a cleanup strategy where we'll go 2D contour. Now side note before I start actually doing this is where on a finishing toolpath in Fusion, compensation type, this is where you could change this to wear. So if you're trying to slowly increase the diameter of a feature on the radial of the tool, on the side of the tool, if you enable wear, then on a Haas control, when you do radius or diameter wear, however you have it set up on your control, you can add or subtract values on there to kind of use your you can compensate your cutter comp. You can cut bigger or less using the control. I'm sorry I'm sounding like an idiot right now, but it's hard to explain without the machine and kind of showing. However, your adaptive toolpaths don't have this, but your finishing toolpaths have this, and it's a very powerful tool in machining because on critical dimensions, a lot of times you'll back the tool out or whatever, whether you add or subtract, and then you'll creep on those dimensions by playing with your radial wear. So whether you're making it cut more or less. So this is where you would enable wear. I'm not going to do it. So if you leave it at the default in computer, you can't do radial or diameter wear at the control. It won't allow you. You can do height wear, but not radial wear. All right, back to our tool selection. Sorry for that tangent, but it's very important later down the road when you get more confident machining. We're going to change our tool. We're going to go to our 1/4 inch end mill. So let's go to my clay mini mill. And that is my tool 3, 1/4 inch flat end mill, select. And we are going to reduce this cutting feed rate to a whopping 15 inches a minute. 15, 15, 15. I'm leaving this baby max at 6,000 RPM. And then we're going to have to select that geometry again. So I'm just going to do the same thing. I'm selecting the bottom down here. And heights, it goes to selected contours. I want to shoot past the bottom, so I'm right down here, bottom height. I'm going to say -0.01. And then let's go to passes tab. Probably going to miss something again and have to come back and fix it. Story of my life. We'll go to smoothing, and we will also utilize feed optimization. And for this one, we are going to leave that default, it looks like, according to my notes. All right, that's looking okay. And here, let's go to our linking. On here, this is where you can adjust kind of how that tool enters the material. And typically, if you increase the horizontal lead and radius, it will roll on more gentle and you're less likely to see a witness mark. So we're going to increase that to 50 thou, 0.05. leave that at 90. I don't need a linear lead and distance, don't care. I'm going to go 0.0. Vertical lead and radius, don't care. All that material's been removed, so I'm going to go 0.0. And we'll leave all that. And if you wanted to, you could try to pick a place where you want the tool to enter inside here. I don't care. We're going to say OK. And this little horizontal, that lead and radius, that's what we're playing with right there. The tool comes down, walks on the part, cuts around the whole thing, and then rolls off. And now we have that pocket clean, so I'm going to say save. We are at the 30-minute mark. So I'm going to go ahead and conclude this as part 1. This is where you should be. And what we still have left is we got to clean out this pocket. We've got to do this blending. We've got to cut that pocket, do the cool toolpaths in there. And we still, I think my next one up is to do a contour, because when we did that adaptive rough, we left material around the walls of this thing. And the adaptive tooling strategies, they leave a lot of marks. So, and around a radius, it's like a bunch of flats. It goes from boom, it just it doesn't do a nice arc. It goes a bunch of little flats, and it's really noticeable when it's machined. So we need to use a finish contour strategy for that one. So this concludes CAM Op 1 Part 1 of the Wasabi Speed Wrench. I will see you for Part 2.